Hello everyone, your Dr. Zia Tahir here. This video tutorial is 3D truss analysis in Abaqus CAE. So the truss is shown here. So it's a three-dimensional truss. All members are made up of steel with modulus of elasticity 29 into 10 raised by 6 psi, Poisson's ratio zero point 0.3, and cross-sectional area 3.093. And the coordinates of each point they are given in feet. So required is deflection of each joint, stresses in each member, and reaction force. So this truss is problem 3.15. So that is problem 15 from chapter 3, trusses of finite element analysis, theory and application with ANSYS. So on 2D truss and then 3D truss, so videos are there. So this is 2D truss or pin joint structure, and then this is 3D truss. In this 3D truss, I have used a different technique for just to model truss. So you can watch that as well for different technique or for the basics of truss analysis. You can watch this video. So truss analysis in Abaqus that has three parts. The first one is modeling, then analysis, and then results. So these three, and these are the steps which you need to follow for modeling, analysis, and results. And I'm going to explain these steps one by one. So there's no system of units in Abaqus. You have to set your own system of unit. It may be Newton meter Pascal, pound inch, PSI, or Newton millimeter megapascal. So it depends like which type of units you are going to use. So in this problem, I am going to use pound, inch, and PSI because modulus of elasticity is in PSI, area of cross section is in inch squared, but the coordinates of these or lengths are in feet, so they need to convert into inches. To start with, need to set work directory where you want to save all the files. So here, this is Abaqus 2020 in a standard view. So file set work directory. So here you can paste the link of your file, your folder. So work directory is set. Next one is save model. So here file, save. So that is the name 3D Trust problem 3.15. So that is being saved and then need to rename that model. So rename. So I rename it as Trust 3D and then problem 3. And remember that to rename model or job, so spaces, full stops, they are not allowed in Abaqus. So that is now model is being saved there and even whole of the file is being saved. So next step is create part. So for this problem, I am using 3D deformable wire planer and then sketch members in the plane. So here in the module, create part. So part, let's say I'm going to say truss 3D deformable wire planer. And approximate size is almost whatever is the double of the size, double of the maximum dimension. So maximum dimension here is 4 feet or 48 inches. So I am going to set it as 100. So continue. So now that is XY plane. So I am going to sketch the members which are in XY plane. So that is X and that's Y. So these two A, E and ED are the members in XY plane. So I'm going to draw those. So to draw these one, so simply use that connected lines. So this is origin and then 48 long horizontal, cancel procedure. Okay, and then again, so that members in XY plane, so they are drawn. So like as this is 048 and this is 48 0 and their Z coordinates are 0 0. So cancel procedure and done. And now that members in XY plane, they are sketched. The next step is create datum point, enter coordinate, and for each node in the truss out of selected plane. So this point C and point B, they are out of the plane. A, E, and D, they are in the plane. So for B and C here, and in the part module, there is datum point. To create datum point, so first I'm going to draw C, which is 002 inch. So it is 0, 0, and 24. 0, 0, and 24. Okay, because sorry, 2 feet is 24 inches, and the other one is 0, 0, minus 2 feet, which is 0, 0, minus 24. So 0, 0, minus 24. Enter. So now in 3D, you can see there is one point C here, and the other one is B point there. I renamed these points as point C and B. Next point is create wire, and wire is point to point, polyline, merge wire, chained wire, and to create all those members. So in the part module again, here is the wire, so planar wire, and I'm interested in point to point, and then here geometry type is polyline, then merge scheme is merge wire, and as method is chain wire. So now need to join all these points. So by clicking add button and then select this point like this origin and with shift, so point B, done. Then again origin to point C, done. So these two are formed, and in the similar way need to sketch all others. So all points joints are connected. So like that is the first, second, then that is the third. Point C with the vertex 2, point B with vertex 0, vertex 2 with point B, vertex 2 with vertex 0. Okay, so that is all done. Okay, so that AD is also in XY plane. So I just uh, explained another way, like if you're not going to draw them in plane, so you can later draw them. So that is now model is created, like it's sketched. Next step is create material, and for that mechanical elastic isotropic material, modulus of elasticity and Poisson's ratio are. E is 29 in 10 raised per 6, Poisson's ratio is 3, and that is steel. So here in the property module, I can create here material. So let's say steel, and then mechanical elasticity, elastic, modulus of elasticity as 29 e raised per 6, and Poisson's ratio as zero point 0.3. So that is a Poisson's ratio as zero point 0.3. So here you can see that steel material is created with modulus of elasticity and Poisson's ratio. Next step in the property module, create section, and that is category beam type truss and need to add cross-sectional area. So in the property module, here is create section. So section truss, beam, truss, continue, and then need to add cross-sectional area, which is 3.093, 3.093. Okay, so here this section is created, and the next one is need to assign section. And here you have section assignment. Okay, so select that one, done. Okay, so when the section is being assigned, so it turned to green. Next step is mesh and seed edge by number and one element per member, and then mesh part and assign element type. So T3D2. So here in module mesh, so that is seed edges. Select all edges, done. Then there are two options, by size or by number. I'm going for by number, and then one element between the nodes. So apply, okay. Then mesh, yes. Then assign element type. So select it and done. And element type is standard linear truss. So T3D2, two node linear 3D truss. So the mesh is done. Next step in the assembly module, create instance. So in the assembly module, here is create instance. Okay, so that you can see that in assembly, now you have that truss. Next step is to create step, and procedure type is journal and then static journal. I am going to rename as static load. So in step, here step module, there is create step and name is here procedure is journal and then static journal. So name is static load, continue. Okay, so here you can see that in step static load is created. So next is you can create field output. So required stresses, displacement, forces and reaction. So here is option to create field output, but there is a field output already here and it contains stresses, then strains. I don't want strains, displacement, rotation, forces, and then contact. Okay, so now field output is selected, so you can request field output of your choice. Next step is to create load, and concentrated force is required step as static load. So here in the load module, you can create load. So that create load. So name is load 1. So static load, concentrated force, continue, and then need to select a point where the load is being applied. So that is the point where load is being applied. And at point A, so in y direction, 250 load is being applied and it is in negative y direction. And then that is a z direction, so 150 is applied in negative z direction. So, similarly, I have applied load at this origin, which is E point. So that is 250 and minus 150. So here minus 250 in y direction, minus 150 in z direction, it is being applied. So both of the loads at point A and E, so they are being applied here. Next step is to create boundary condition, and boundary types are displacement rotation and step as initial. So B, C, and D, so these are all three pin sports, and on pin sports, so there are reactions only, no moments, so translational displacement need to set 0. So here in the load module again, so that is boundary condition. So because all these three boundary conditions are the same, so I can simply select all these points and then create one boundary condition, or you can select them separately. So let's say boundary condition 1, mechanical displacement rotation, continue. I'm going to select this point, done, and U1, U2, U3, they are 0. Okay, so that is the first boundary condition. And now for these two sports, I am going to give them combined boundary condition. So boundary condition initial, displacement rotation continue, and I am going to select these 2 points. So done, and then U1, U2, U3, UX, UY, UZ, they are 0. So now second boundary condition is being applied at that point. So now all boundary conditions are applied. So now, because modeling part is done, the next is job, create job, data check, and submit. So in the module here is the job. So here is to create job, and I am giving it name at Truss 3D underscore problem 3. Okay. So now job is being created. So by here job manager. Okay. So first need to apply data check. So data check will let you know that if you have done, like in the modeling, all necessary steps are performed. So that data check is running. So data check is complete without any error, and then you need to submit this job. It will take some time to run this job. So job is completed. Otherwise, you can see here in the model tree, so that job is completed. So analysis is done. So now result visualization. So in the visualization, field output dialog, displacement, then stresses, and then reaction forces. So in the job manager, you can click on the results, or here in the model tree, click on the results. So that is the results, and it go into the results now, and you have that results, or otherwise you can file open. So here is that ODB, and in the results now you can see that is deformed shape. Okay, so first is displacements, and for better visualization you can go view and then ODB display option, render beam profile, apply. Okay, so that is beam, sorry, so that is these are the U, and then that is U1, U2, and then U3. Next, stresses S, and for normal stresses it is S11. So these are the stresses. Okay, and then for the reaction forces RF, so those are the reaction forces. So this way you can visualize required results. The next step is using prob values of U, and need to display and then save those displacements or deflection as a file. So now U and magnitude here, and this is the prob. That is the prob. So in the prob for displacements, need to go nodes, okay, components all, display group all. and then I'm going to select all that. So now the displacement at each node, but it's not very clear. So I need to go view, graphic options, and need to change viewport background to white. And these numbers, they are tiny. So you can go here and then colors labels, and you can change set font. You can increase the font size to 14, okay, or you can style bold. Okay, so these are the now these are the displacements. So at fixed board, so that is around 0, and the rest are the values. So you can create write to file, okay, and you can give it name. So given RAM Truss 3D problem RPT, okay. So now report is being created. So cancel and then yes. So in the work directory, so that Truss 3D underscore problem 3 report is created, and that report can contain, like, for each node how much is deflection. Okay, so these are the deflection coordinates, and then these are the displacements at each node. The next step in the visualization, need to get stresses, which are prob values S11, and then stresses are for the elements, and for that elements need to get components all direct, and display group is all. So now here S and then S11, okay, and then prob. So here prob elements, components all direct, position integration point or centroid, display group all, and then here you can see these are stresses at each. So I can just, in the label, I can change its font to slightly bigger, 14 bold, apply. So that is, so apply, okay. So now, so these are for each node, and then stresses at those nodes. So these are the stresses, and then they can write to the file. So append to the file on the same, which is task 3D problem. So that is okay. And now they are added next to the displacement here. So these are the stresses, they are added in that report. Next step is reaction forces, and for that one, reaction forces must be on the nodes, and then components all, and then display group. So here now reaction forces, okay, so reaction forces probe, and for reaction forces they are at nodes, display group all, and then here are the reaction forces now, like reactions 0. So these are the reaction forces at sports. So 1, 2, and 3. So I can write to the file, okay, cancel, yes, and it is being added in the report file after stresses. So these are the reaction forces. So these are the here. So these are original coordinates, deformed coordinates, and then these are reaction forces. So now the summary. So in Abaqus CAE for 3D truss, you need to perform modeling, analysis, and results. And for 3D truss, you need to create part 3D deformable wire planar, and then need to create datum point, and then need to connect vertices and datum point using wire. They need to create material by assigning E and new, and then create section. Here is a beam type truss, and then need to assign section math. Like for truss analysis using FEA, so only one member is considered between two sports or between two joints. So then number is one, and then element type assigned is T3, T2. Then create instance, create steps, step with the static journal here, and then need to assign create field output or need to check field output and then loads, and loads are being applied in X, Y, and Z direction, and then boundary condition. So boundary condition, displacement, and rotation. So then you need to create job, and data check is important to check if all modeling necessary steps of the modeling are performed, and then need to submit, and then to get displacement need to prop value at the nodes, and then you can write a file, so this will be saved as a report file. Then similarly for normal stresses S11, and for reaction forces RF you need to apply. I hope you find this video helpful. Thank you very much for watching.